Hi everyone, yeah, my name's Rob Harding. I'm the engineering manager for Telent's traffic business. As Darren points out, you'll see I've got no innovator with me. That's really because there wasn't one specifically relevant to what I'm talking about. There's various innovations, various products that I'm going to talk about. We're pretty vendor agnostic. We tend to do our innovations on talking to customers, and then we'll go out and see who the most relevant person is to join us on that. So you will see throughout the slides that we've done stuff with Smart Micro, with Vivacity, with EarthSense, with AirScan, all those kind of innovators in their fields. That's a good enough excuse, Darren. So yeah, there's a couple of slides on what Telent do in case you've not heard of us, and then a bit of a delve into the products themselves. And hopefully that will just spark some ideas on how together we can help relieve Darren of some of his money. So Telent, who are we? We're a £500 million company. We employ 3,000 people in 1,200 engineering roles. We've got 42 regional sites across the UK, and our HQ's in Warwick. There's probably 5 or 6 of those specifically to do with traffic. We're much wider than that. We're big in all sorts of transport, very big in rail, emergency services, network infrastructure and the utilities, the defence industry and higher education. There's some examples there. I haven't got, I thought there might be a notes screen up here because I haven't seen this podium before, but there's not. So a couple of examples. We completely manage Merseyside Fire and Rescue's IT systems. We've done that for 20 years. We're deploying a full, across the UK, fibre network for the Maritime and Coast Guard Agency. That includes about 165 remote radio connections to lifeboat stations. We've done various Wi-Fi projects for people like the University of Exeter, and some of our traffic customers are on there. So specifically to traffic, in terms of traffic signal maintenance, in London we look after 1/3 of their signals and all of their CCTV assets. Outside of London we maintain over 7,000 traffic signals sites for 32 different clients, and that includes over 50,000 traffic signal heads. Our largest customer is Kent. They've got 775 sites, and we've been the incumbent in Cumbria and West Sussex for around 25 years, and Kent and Gloucestershire for 20 years. 40% of the signals that we maintain are our own, but the other 60% are third-party manufacturers like Unex and Swarco. And a little fun fact for you there, we install 75 miles of signal cable each year, which is the equivalent of Warwick to Wembley Stadium in a straight line. The map on the right shows our coverage from Cumbria in the northwest down through West Yorkshire, North Wales, Oxfordshire, Wiltshire, and then the southeast with Essex, Kent, East Sussex, West Sussex, and Southampton's that little isolated blob at the bottom. We've got an in-house design services team led by a guy called Phil Scoffham. They've just got years and years of experience of, quite a lot of them are ex-authority, UTC managers and the like. So vast experience at designing junctions, validating junctions, producing the drawings, doing controller specifications, doing scoot and mover design and validation. So if you need any help in that respect, give us a shout. So onto the product. So I say this is really, rather than giving you something to bid for the ITMF, it's showing you the sort of platforms that we have that we can help you to come up with your ideas. So we've got our own traffic signal controller, the Optima 2, the electronics, the main electronics rack is produced by Swarco in Denmark, but it's all our own software. It's all written in-house by my team in Warwick. It's Topaz registered. Optima 3 will be arriving later this year. That's just an electronics refresh, all the same software initially, so with the door shut you won't know it's any different. That shows you the architecture. So I said at the bottom there, Swarco provide the electronics and the hardware drivers effectively, and then everything above that, all the apps are written by my team. Makes it very flexible for us to produce whatever we like really. So we've done the traditional stuff like UG405, Mover 8, our own remote monitoring, but then we have done some innovation, bus priority. There's a slide on that later. So as I say, we can develop whatever we like. So Mover 8, I think we were the first ones to get that running integrally. You can see TRL's web page embedded there. Allows you remote access, allows you to download any of the Mover logs through that from the comfort of your desk. We developed a Vivacity camera interface. This was when they were being deployed in Leeds to send data back to the UTC. It was noted that they're a very capable sensor for the roadside as well. So we developed an IP interface to the camera itself. That is the controller web page, and so you might be able to see there that you can say things like, if there are more than 3 pedestrians in this zone, then set this control bit in the controller. The way it can differentiate people is pretty impressive. It can tell the difference between a bus and a lorry, a wheelchair user, an electric scooter user. And we're also looking at doing that with other detector interfaces. So, as I mentioned, some of the other people we work with, like Smart Micro, FLIR, and AGD. And I think someone mentioned earlier that we're part of the ARTSM working group that's looking to try and standardise that interface so that we don't have to keep developing against these proprietary interfaces. Count data, that's something that we added into the controller, so you can count any detector input, so loops or push buttons or any of those camera detects. But you can also detect, you can also count phase activations by colour as well. So if you wanted to count, how well used a pedestrian crossing was, you could count that. You could count push button activations versus how many times the green man actually ran, and you can download that data through the hub. The hub goes around collecting all that data every night. On the controller itself, you've got 2 or 3 days history. So there's a use case here in West Sussex. They implemented an early start cycle scheme after a fatality at this junction, and they wanted some data to show whether it was making any difference. So you'll see that well, it's a bit difficult to see, but in that quarter of an hour on the 14th of April, the approach ran 11 times. 11 cycles were detected, and twice out of the 11 times, the cycles actually got an early start. The rest of the time, the light was already on green when they got there. Remote I/O, so that was a way of passing detector data or event triggers over an IP network. It runs on the controller and our own outstation, and the use cases are sort of point-to-point, doing mover linking, using Ethernet cable rather than multi-core if you're fairly local. But we can also pass that sort of information via the Optima hub. So if there's any kind of event that you want a controller several miles away to know about, then you could potentially bounce that message off of our servers. So, for example, passing bus triggers down a corridor. And then also, and this is something we've not really developed anything to use the mechanism yet, we could originate those messages from the hub. So, for example, we could change the timing set on a controller based on a pollution threshold or any other kind of event that you can think of, really. We're waiting for you guys to come up with use cases for that one. There's a case study of remote I/O. It's a park and ride site in Leeds. There's 4 controllers, up to 450 metres between them. It's got a fibre network between them, and we use it for mover linking to avoid long cable pulls. I'm told it worked first time. These controllers are fully loaded, so they've got Integral Mover 8, UG405 and Bus Priority all running on them. That's our own outstation. It's got pretty much all of the apps that I spoke about on the controller also run on this. So 4 streams of Mover 8, UG405, the Vivacity camera interface, and the RT Bus Priority. And the point of this is you can add any of these facilities to any other controller, and we could produce other apps. So we've taken that and produced the TFL next-gen remote monitoring, SNMP-based remote monitoring, because it's a Linux-based processor on there, and again, my software engineers can write different apps or entirely new software on that. So if you need an outstation on the street for any of your ITMF ideas, that could potentially be it. The Optima hub I mentioned, so this is an evolution of our remote monitoring. We recognise it was becoming much more than just remote monitoring when we started to integrate things like pollution sensors and cameras and the remote I/O. So it's a hosted service, accessed by browser, works with any controller, and we've got over 2,100 sites now across 18 different authorities on this system. And I mentioned some of the modules that we've developed. There's 1 or 2 slides on those. Remote monitoring, you can get to the handset, pretty standard stuff remotely. There's historical fault database, remote web pages of anything that you put on the system, really, not just our own controller, and a way of opening up straight to the Google Street View of the junction with the congestion data turned on for you. CCTV, this was one that was asked for by one of our customers. They were having problems with the PTZ cameras not working. Camera people were blaming the comms were blaming the cameras. So they asked us if we could do something. So we installed the fairly basic IP bullet cameras, and they're perfect for situational awareness. We're not trying to do ANPR, we're not recording. It just gives you a sort of situational awareness of a junction. Works, providing you've got a decent 4G signal, it works over that. We dial the camera frame rate down, we limit the bandwidth so that it works pretty well over 4G. So bus priority I mentioned, we've rolled out a 5-junction corridor in West Sussex, and we're in the process of rolling out about 30 sites in East Sussex. The point being, you don't have to add any extra equipment to the buses. So the way it works is the authority defines the virtual loop positions around the junctions, and that gets uploaded to the likes of VIX and Ticketer. They know where the buses are because of the ticket machine. So when the bus passes that virtual trigger, the VIX or Ticketer server passes that data to the Optima hub, and then we're able to initiate the priority mode on the controller, whether that be through Mover 8 or whatever, a hurry call or whatever you want. And that's on the controller side of things. So that's a standard RTIG message down the left-hand side. Gives you the traffic signal ID, the priority of the thing approaching, the movement, is it going straight ahead, turning left, and how late it is. And then you can set some rules on the controller to say, if this bus is turning left and it's 10 minutes late, then set this bit in Mover. Air quality, we've integrated a couple of sensor types here, the Earth Sense and Air Scan. You can get real-time and historical data. We put 2 corridors in Gloucestershire there, that's Gloucester, and then behind it is Cheltenham. And an interesting use case that is close to being turned on, this is in West Sussex, and we've put a sensor in the centre of the junction and one on each arm. And we're able to set a threshold in the Optima hub to say, if you're close to or breaching this threshold, let's try and change the mover data set to see if we can clear the problem arm. At the minute, it's just, we're in the process of deciding what those thresholds are. So it'd be quite interesting to see if we can have an effect on the pollution by changing timing sets. In April last year, we acquired IDT, and that gave us some nice products. So an iMesh router, an iCell 4G router, and these are sort of internal and external variants. So you can put a router up a pole, as the picture of that, and also Mesh I/O, which is a way of passing digital I/O over IP, wireless IP normally for this. So what is iMesh? It's a series of nodes connected by wireless links. Gives you multiple paths through the network, and it'll auto reconfigure in the event of a node failure. So it can be very widespread. That's a picture of Bracknell town centre, completely covered by mesh, or smaller clusters. So there's an example down there with 8 controllers all connected with one backhaul. Set of communications, but you can have much simpler use cases as well. So the bus station VMS signs in Leicester are connected together, just an end-to-end, no backhaul required. They just need to be connected together. 2 link controllers with no comms, or for example, detection that's too far down the road to run a comms cable. As a use case of this, up in Ambleside, you've got a junction there, J1, and 2 pedestrian crossings, P1 and P2, and they're completely uncoordinated. So the operation of the pedestrian crossings was affecting the throughput of the junction. So some mesh was put in. There's some pictures there of the stuff up a pole, and some remote loop detection down there, bottom left, to link everything together. And you can see there the improvement in throughput, going from around, it was 600 cars every half an hour up to 800, 1,000 cars, so real success on that. There is journey time monitoring that can work in the routers and the iMesh nodes. It's a system that sniffs for Wi-Fi MAC addresses, and that outputs the data in the standard UTMC ANPR MIB, so that's compatible with any UTMC compliant central system. I think that's actually a Unix system, top right. So in summary, we've got the platforms, the controller, the outstation I mentioned, the hub, and all the comms facilities. We've got the people. I've got the product development team working for me, design services, lots of boots on ground, and we've got wider skills. As I said in the first couple of slides, Telent are a very big business into lots of different things, and all of those people are available to us. So if any of that sparked any ideas, then come and talk to us. And that's my email address if you want to drop me a line about any of this or anything that the wider Telent do. Thank you.